2002 National Electrical Code, Section 210.12, addresses arc fault circuit interrupter protection. This section mandates that all 15 amps and 20 amps branch circuits that serve outlets within dwelling units must be protected by arc fault circuit interrupters, or AFCIs. This requirement encompasses both receptacle outlets and lighting outlets. It's important to understand why the code includes lighting outlets in this protection scheme. Arc fault circuit interrupters are designed to prevent electrical fires. These fires can be caused by arc faults, which are essentially brief, high-energy electrical discharges. These discharges have the potential to ignite flammable materials that might be nearby. Lighting outlets, like receptacle outlets, are susceptible to arc faults. For this reason, the code requires them to have the same level of protection. The specific part of the code that is relevant here is NEC 2002-210.12 subsection B. It states that dwelling units must have all 15 amps and 20 amps, 120 volts branch circuits that supply outlets in habitable rooms protected by a listed arc fault circuit interrupter. If there is a disagreement with an electrical inspector regarding this interpretation, here are some things that can be done. Firstly, provide a copy of the NEC 2002 Section 210.12. Secondly, provide examples of previous inspections that approved the practice of excluding lighting outlets from AFCI protection. Thirdly, supply documentation from electrical professionals or manufacturers that supports the interpretation. It is important to maintain a respectful and professional demeanor when interacting with the inspector. Providing clear and concise evidence and engaging in a constructive dialogue should help resolve the issue and ensure that the electrical installations comply with the National Electrical Code. Arc faults can occur in various ways. For example, damaged or deteriorated wiring can create a path for electricity to jump across a gap, producing heat and potentially igniting nearby materials. Loose connections in outlets or fixtures can also cause arcing. Even something as simple as a nail or screw piercing a wire inside a wall can lead to an arc fault. Because these situations can arise in lighting circuits just as easily as in receptacle circuits, the NEC mandates AFCI protection for both. Now let's delve a little deeper into the technical aspects of arc fault circuit interrupters. There are typically two main types of AFCIs: firstly, branch/feeder AFCIs, and secondly, outlet circuit AFCIs. Branch/feeder AFCIs are installed in the electrical panel and provide protection for the entire branch circuit. Outlet circuit AFCIs, on the other hand, are installed at the first outlet on the circuit and protect the downstream wiring and outlets. AFCIs work by monitoring the electrical current flowing through the circuit. They are designed to detect the unique characteristics of arc faults, such as the erratic and high-frequency waveforms that these faults produce. When an AFCI detects an arc fault, it quickly trips the circuit, cutting off the flow of electricity and preventing a fire from starting. The speed at which an AFCI trips is crucial. They are designed to trip within a fraction of a second, often less than a tenth of a second, to minimize the risk of ignition. This rapid response is what makes AFCIs so effective at preventing electrical fires. It's also important to understand that AFCIs are different from ground fault circuit interrupters, or GFCIs. While both devices are designed to protect against electrical hazards, they do so in different ways. GFCIs protect against ground faults, which occur when electricity flows through an unintended path to ground, such as through a person touching a live wire. AFCIs, as we've discussed, protect against arc faults, which are characterized by arcing or sparking. GFCIs are typically required in areas where there is a high risk of water exposure, such as bathrooms, kitchens, and outdoor locations. AFCIs, on the other hand, are primarily required in residential living areas to protect against electrical fires. When installing AFCIs, it's important to follow the manufacturer's instructions carefully. The devices must be properly wired and grounded to function correctly. It's also a good idea to test the AFCI after installation to ensure that it is working properly. Most AFCIs have a test button that simulates an arc fault, allowing you to verify that the device trips as expected. It's also recommended to periodically test AFCIs throughout their service life to ensure that they continue to provide reliable protection. If an AFCI trips frequently, it's important to investigate the cause. Frequent tripping can indicate a problem with the wiring, the appliance is connected to the circuit, or the AFCI itself. It's best to consult with a qualified electrician to diagnose and resolve the issue. Ignoring frequent AFCI tripping can be dangerous, as it could mean that an arc fault is present and the AFCI is working to protect against a fire. Now let's consider some practical examples of how AFCI protection works in a residential setting. Imagine a living room with several outlets, including those used for lamps, televisions, and other electronic devices. All of these outlets are connected to a 15 amps or 20 amps branch circuit that is protected by an AFCI. If a lamp cord becomes frayed and starts to arc, the AFCI will detect the arc fault and trip the circuit, cutting off power to the lamp and preventing a fire from starting. Similarly, if there is a loose connection in a wall outlet that causes arcing, the AFCI will trip, protecting the wiring and preventing a fire. In the case of lighting outlets, AFCI protection is equally important. Consider a bedroom with a ceiling-mounted light fixture. If the wiring inside the fixture becomes damaged or if there is a loose connection, an arc fault could occur. The AFCI will detect the arc fault and trip the circuit, preventing the fixture from overheating and potentially igniting nearby materials such as curtains or bedding. It is very important that when doing electrical work to comply with the most current electrical code, which may be different from the 2002 NEC. Codes are updated periodically to reflect new technologies, safety standards, and best practices. Using AFCI protection is a very important part of ensuring electrical safety in homes. The use of AFCIs can significantly reduce the risk of electrical fires, protecting lives and property. While it is true that in the past some inspectors may have allowed the exclusion of lighting outlets from AFCI protection, the current interpretation of the NEC clearly requires that all outlets on 15 amps and 20 amps branch circuits in dwelling units, including lighting outlets, be protected. By understanding the code requirements and the reasons behind them, you can ensure that your electrical installations are safe and compliant. To further clarify the scope of NEC Section 210.12, it's helpful to consider some specific examples of what is and is not covered by the AFCI requirements. Firstly, the requirement applies to all 15 amps and 20 amps, 120 volts branch circuits that supply outlets in habitable rooms of dwelling units. Habitable rooms are generally defined as rooms used for living, sleeping, eating, or cooking. This includes living rooms, bedrooms, kitchens, dining rooms, and family rooms. Secondly, the requirement does not apply to circuits that supply only appliances, such as refrigerators, washing machines, or dishwashers. These appliances typically have their own dedicated circuits and are not considered to be part of the general lighting and receptacle circuits that are covered by the AFCI requirements. Thirdly, the requirement does not apply to circuits that operate at voltages higher than 120 volts. For example, a 240-volt circuit that supplies an electric range or a clothes dryer would not be subject to the AFCI requirements. Also, the requirement does not apply to circuits in non-dwelling unit occupancies such as commercial buildings or industrial facilities. These occupancies have their own specific electrical codes and standards. It's also worth noting that some local jurisdictions may have additional requirements or amendments to the NEC. It's always a good idea to check with the local building department or electrical inspector to ensure that you are complying with all applicable codes and regulations. In addition to the specific requirements of NEC Section 210.12, there are other related code sections that address electrical safety in dwelling units. For example, NEC Section 210.8 specifies the requirements for ground fault circuit interrupter GFCI protection in dwelling units. GFCIs are required in areas where there is a high risk of water exposure, such as bathrooms, kitchens, and outdoor locations. While AFCIs and GFCIs provide different types of protection, both are essential for ensuring electrical safety in homes. It's also important to follow good electrical practices when installing or modifying electrical wiring. This includes using properly sized wires and cables, making secure connections, and ensuring that all electrical boxes and enclosures are properly grounded. Improper wiring can create a fire hazard and increase the risk of electrical shock. When working with electricity, it's always best to err on the side of caution. If you are not comfortable working with electrical wiring, it's best to hire a qualified electrician to do the work for you. Electricians have the training, experience, and tools necessary to perform electrical work safely and correctly. Let's consider the evolution of AFCI requirements in the National Electrical Code. The initial introduction of AFCI requirements focused primarily on bedroom circuits. Over time, the code has been expanded to include more areas of the home, reflecting a growing understanding of the prevalence of arc faults and the importance of protecting against them. The 2002 NEC represented a significant step forward in AFCI protection by extending the requirements to all outlets in habitable rooms. Subsequent editions of the NEC have further refined the requirements for AFCI protection, addressing issues such as nuisance tripping and the compatibility of AFCIs with different types of lighting and electronic devices. As technology advances, it's likely that AFCI requirements will continue to evolve to provide even greater protection against electrical fires. It's also important to understand the difference between AFCI protection and surge protection. Surge protection is designed to protect electronic devices from voltage spikes, which can damage sensitive components. AFCIs, as we've discussed, protect against arc faults, which are characterized by arcing or sparking. While surge protection is important for protecting electronic devices, it does not provide the same level of protection against electrical fires as AFCI protection. In summary, the NEC 2002, Section 210.12, mandates that all 15 amps and 20 amps branch circuits that supply outlets in habitable rooms of dwelling units must be protected by arc fault circuit interrupters AFCIs. This requirement includes both receptacle outlets and lighting outlets. The purpose of AFCI protection is to prevent electrical fires caused by arc faults. If there is a disagreement with an electrical inspector regarding this interpretation, providing clear evidence and engaging in a constructive dialogue should help resolve the issue and ensure that the electrical installations comply with the National Electrical Code. Using AFCI protection is an important part of ensuring electrical safety in homes, and it can significantly reduce the risk of electrical fires, protecting lives and property. It is also important to consult the most current electrical code, as codes change and get updated over time.